Natural gas, the next topic in a series of energy topics that we'll be discussing in the coming weeks. Confused about natural gas? A little shocked about sitting here having to listen to a lecture about natural gas? Maybe a little bored? Well, natural gas is very important and probably going to impact our lives for years to come, so we need to know a lot about it. So let's start with the basics of natural gas. All right, natural gas is a fossil fuel, all right, just like the others. It is a mixture of hydrocarbon gases. Remember, that's where the energy comes from. All energy is released in that hydrogen-carbon bond. All right, and in this particular case, the carbon-hydrogen bond comes mostly from methane gas. Okay, natural gas is mostly methane. Somewhere between 80 to 95% is methane, and the others make up, anywhere from 5 to 20%, depending on the quality of the gas. All right, so we're basically talking about a hydrocarbon of methane. But what makes natural gas a alternative to oil and coal is that it burns so much cleaner. It produces far less carbon dioxide than oil, and actually about half the amount of carbon dioxide than coal. So we look at it as an alternative to those two. So we need to explore this as a possible option, and we're going to be studying that in a lot of detail here in this lecture. All right, how do we get natural gas? Well, natural gas, being a fossil fuel, is formed just like oil from marine organisms through their depositing at the bottom of the ocean. All right, forming layers of shale that has a lot of the organics still in it. Those organics are then modified by heat and pressure in the oceans and turned into oil. If you take that heat and pressure even further, you'll form natural gas. Because oil and natural gas are light, they usually float to the top of the shale formation, just like floating on water, and get pushed to the top of these geologic domes that occur underneath. And then all we have to do is go and drill down into the pocket of natural gas, and we can pull out that natural gas from the earth. And then as you continue down, you can all go a little bit further and get the oil. So what you're looking at is when you drill for natural gas, you get that type of structure where they're actually drilling down, they reach the natural gas. Once you hit the natural gas, there's enough pressure where all you need to do is put that type of device there, and the natural gas will come out on its own. Okay, that's the traditional way of getting natural gas. And the way we've been doing it for years and years and years. Where's the natural gas in this country? Well, if you just look, these are proven reserves. This does not even include what we think of possible reserves. All right, but the proven reserves, if you notice, there's a band going from the Gulf of Mexico straight up through Texas, all the way up through Wyoming. Okay, up that way. Then if you notice also over towards the East Coast, you got some of the mid-Atlantic states having some of that, which we'll get to shortly. Natural gas has a lot of great uses. There's some great potential here as an alternative, or what we call a transition fuel, from what we are using today, oil and coal, to what we'll be using in the future. It accounts for about 25% of all United States energy, and it basically is used three ways: residential, commercial, and industrial. And I think this all is just basic information. When we're talking about residential, here we're talking about in your homes where you need it for heating and cooking, and mostly, I'll tell you what, the heating is where you get the greatest benefit from it. Many homes use it because it is a cheap alternative to oil heat or electrical heat, things like that. All right. Now, of course, in order to get it there, you've got to have pipelines getting it to you. But luckily for the United States, it is abundant. We have a large supply that's going to last us well over 100 years. It's found underneath our own land, and once you extract it from the earth, you can easily transport it through pipelines to where you need it. It gives you a high energy yield. Okay, the ample supply, like I said, is anywhere, in this case, this is predicted Right now, our predictions go even higher, but we can sort of take it on the high end, around 200 years of natural gas, if we continue to extract it the way we are. And it's also going to be used as a fuel source for the future of fuel, which could be fuel cells. And we'll get into that at a later date. So it has tremendous potential and tremendous ability. In 2002, it provided 53% of the heat in our homes and 16% of our electricity. But by 2020, our increased use of natural gas will push that number and make it about 1/3 of all of our country's electricity. So you see it's going to play a major role in our future energy policies in the United States. All right. Again, it's a great transition. All right. Cars can be easily modified to run off of natural gas. Okay. And the big problem with a lot of our other energies is that you can't store it, but natural gas, once you pull it out of the ground, you can transport it from one location to another, and you can store it for years and years to come. So it has tremendous ability to help us out. Today, where are we using natural gas? Most of our natural gas is used to make electricity in the country. Okay. Yet we also use it in industrial processes. So many of the industries that need the heat and energy to produce goods are going to use natural gas because right now it's a cheap alternative. But just behind that is our residential use. Okay, where we use it in our homes for heating the homes and cooking and things like that. So it has tremendous influence within our society. And that is only going to increase as natural gas is produced more and more. Whoops. This is a very important picture. It's not going to give you a whole lot of notes to take, but it's something an image you have to keep in your mind. This is the infrastructure already established for natural gas. These are gas pipelines, all right? And the blue ones are the interstate, the red ones are intrastate or within a state, and you could see massive amounts of pipelines going all over the country which can carry this natural gas. And that's going to be very important. If you look on the East Coast over where we are, you can see we have major pipelines going up and down the East Coast. Where we can move and transport natural gas. And in fact, if you see very closely, you can see a pipeline, going all the way down into the Gulf for bringing up natural gas for our homes here in eastern Pennsylvania, where it originates all the way down in the Gulf of Mexico. So tremendous amount of infrastructure already in place for natural gas so that we can take this gas and move it throughout the country. And these pipelines are buried underground. A lot of times you don't even know they're there, but if you see these cuts in the woods as you go up and down mountains, those cuts are often for either power lines for electrical use or for underground gas lines. We have a tremendous supply of natural gas in the United States, which also makes it a valuable resource for us. Who has the most natural gas in the world? Russia. All right, on every single test, the AP question is what country has the biggest supply of natural gas, and these are proven reserves. It's going to be Russia. All right, then you have a couple countries in the Middle East, and then here we are sitting fourth with a fairly large amount of natural gas. So we have tremendous potential to use this gas to keep us energy independent, all right, by using the energy produced in the United States. But again, no question about it, Russia leads the world in the amount of gas underneath their land. All right. Another tremendous benefit, which I think this graph shows better than any other graph, is the cost. When you're looking at the cost of natural gas versus the other forms of energy, you can see the cost of wind, all right, the cost of geothermal, here we go, blue, biomass energy, okay, solar, but then you go talk about solar cells or photovoltaics, wave, but you just see the cost. But look at coal and then look at natural gas. Costs are very, very low, all right, which gives us this advantage and helps us keep energy cheap and available to many people in our country. So it's just this Tremendous advantage. Now, we also can use something called CNG, or what we call compressed natural gas. This is called compressed natural gas. All right. Now, there's two different types. There's compressed natural gas, all right, where we can take natural gas, compress it into a high-pressure container, all right, and put that container in a back of a car, which you see right here, and then we can, and by the way, we can fuel it this way, as you can see, it's just with almost like a regular pump, and then we can have the car run off of natural gas rather than gasoline. Tremendous advantage. Compressed natural gas is wonderful. It works very easily in cars. You need very little adjustment to your car to make it work. The only problem is compressed natural gas is not something you move and distribute across the country. All right, it's gas, all right, that's compressed into a tank, and it's very difficult to take that gas and move it from one, say, fill-up station to another to another. So we have a second, which might have a little more potential, called Liquefied Petroleum Gas, LPG. All right, Liquefied Petroleum Gas. All right, where in this case, all right, you're going to liquefy it, and it's almost like a substitute for compressed natural gas, but this time you can pump it, you can put it in a tanker truck, you can take it different places, you can put it in gas stations where cars can be filled up with this liquefied petroleum gas. So it can either be compressed where it's still a gas, or you can liquefy it. All right, chill it and liquefy it. All right, both have their disadvantages, but they both have tremendous potential as energy sources for transportation, which is the key here. I put this picture in because I wanted to show you that it's happening right near us. These are the Penn State buses that go on Penn State's campus and through town, as you can see here. They run entirely on compressed natural gas, and they have their own fueling stations, which you see in the lower left-hand corner. But Penn State is proud, and they advertise this, that all of their buses run off compressed natural gas. So why don't we use natural gas in our vehicles? Why doesn't everybody use it? It's cheap, all right? It has a high energy yield. What's the problem? Well, the problem is there's several, and I think you can think about some of the problems. All right. One is that compressed natural gas is not easily transported where you need it. You have to go and change it to a liquefied petroleum gas, which has its own downfalls, but it's just not easily transported. But I think there's even a bigger reason than that. Okay. The problem is we lack the infrastructure. We have an infrastructure that's set up for oil, for burning oil for transportation. We don't have an infrastructure set up for natural gas, which means this. We don't have gas stations that pump natural gas. So if we don't have gas stations that pump natural gas, then who's going to buy a natural gas car? But if you try to sell natural gas cars, all right, you can't sell a natural gas car to somebody because there's no pumps to fill up your car. So no matter which way you look at it, we need to have an infrastructure in place first before we can start selling these vehicles. The problem is who's going to pay for the infrastructure? And we're going to have to change our infrastructure from oil tanks, basically, to natural gas tanks. And that lack of infrastructure, I think, is the main thing holding us back. Because cars run perfectly well, and vehicles run perfectly well on natural gas. But I think that lack of infrastructure. I can't buy a natural gas car because there's nowhere for me to fill it up. And nobody's going to build a pumping station for natural gas if there are no cars. So it's a catch-22. All right, and there's a third one. I don't think this is a big deal, but unfortunately some people do. and that is a fear of the gas exploding. Because although I don't want you to put this down as an answer on tests, because I don't really like this one, but I just want to let you know it is real. When you carry a tank of gas, of pressurized gas in the back of your car, people will fear that a little bit. So there you go. All right. Now things change. Things change dramatically, and they change dramatically because of something we discovered fairly recently, maybe 10 years ago. Between 5 to 10 years ago, we really started this extraction of shale gas. Okay, it's a new way of getting natural gas from the earth. Before, we would just drill down, find the right spot in the earth, drill down, all right, drill a hole in the earth and find it. The hard part was, if here's the surface of the earth, you had to find this geologic dome where the natural gas was. And so as a geologist up here on the surface, you can't see what's down there. And you had to go find it. And if you told your company to drill, you thought it was over here, and you told them to drill straight down here, you hit no gas. You failed. You had to drill directly in the right spot. Well, now that's all changed. There is a huge supply of gas sitting down there in the earth, all right, in shale. So this is natural gas that has not come out of the rock and created a pocket of natural gas in the layer, but rather it's still within the rock. So what is shale? It is a sedimentary rock, okay, that forms in deposits of sand, clay, and here's the key, shells and organic matter in bodies of water. Okay, it's great because it's where the natural gas and petroleum form, and that's where you find the reservoirs. Okay, now the petroleum and the natural gas can now actually be extracted from the rock itself, not in just cracks or pore spaces, but within the rock itself. So you can find a layer of shale and be able to drill in it, and we found a way to get that natural gas right out of the rock itself. And that's what we're going to be exploring next. Why is this so important for us, especially here in Pennsylvania? We just happen to have a large supply of shale, and we give this a name. This area, whoops, I have to go back a second, I apologize. This area on our or under our ground, where there's a layer that has a huge amount of natural gas sitting in the rock layer itself. It's a very thick rock layer called the Marcellus Shale. All right, it was a shallow inland sea that stretches right across eastern United States, all right, and right through Pennsylvania. All right, and it just has a large amount of natural gas in it, as you're going to find out. All right, let's take a closer look at this. Here is where the Marcellus Shale is actually located in Pennsylvania, and you can see a large chunk of our state is immersed, or I shouldn't say immersed, but rather sitting on top of this Marcellus Shale, which has the oil and especially natural gas in it. If you want to look at exactly where it is, there's a great picture for you to see. Right through Pennsylvania up to New York, down into West Virginia. Marcellus Shale. There's 50 trillion cubic feet of natural gas, they think, in these rocks. And they want to get it out. So what are they going to do? They're going to go and drill. All right, now to get the gas out of shale rock is different from extracting it the old way. This new process is much more difficult, but we discovered this idea of directional drilling and the idea of fracking, and now it has become a reality where we can actually get to this gas. And you can see what that has done. All right, when you're talking about how we actually get natural gas in this country, for years and years and years, okay, you were looking at different ways of getting gas, but the one thing for certain was that shale gas only was a small percentage. Then you can see right around here, we discovered this new way of hydraulic fracturing, and look what happened to the percentage of our gas coming from shale gas. And look what's going to happen to that percentage in the years to come, where that percentage is now going to be huge compared to the other ways of getting natural gas from the earth. It's going to become the number one way. In fact, it's almost number one right now. All right, in just a few years, it will be number one. So this new hydraulic fracturing process enabled us to get shale gas where we never could before, and it has opened up a whole new boom in energy. All right, this is what we call directional drilling. It's called directional drilling. This is where you can drill at one location, put a rig here, drill down, and then when you get to the layer, in this case a shale layer of natural gas and shale, all right, it could be very deep. Here's the aquifer where all the water is. Okay, here's a couple of veins of coal, which you're not interested in. You want to get all the way down to the natural gas. Then you can take the drill and actually turn it horizontally and drill horizontally for great distances, so that even though your oil rig is here, you're going to be drilling underneath somebody else's house for that natural gas. Now this is sometimes thousands of feet down in the earth, but the idea is that you can pull out their natural gas. And it's a new technique, directional drilling. All right, and we also have the second thing that we need to get this shale gas out, and that's hydraulic fracturing. What exactly is hydraulic fracturing? Best way to describe it is for you just to view this quick, simple video. It will explain it, and I think the graphics are wonderful. Pay close attention to how the well is drilled, and then how fracking is used to extract the natural gas. It's going to become very important. You're going to have to understand this process. Watch this video very carefully.
Hydraulic fracturing has provided safe extraction of oil and natural gas from underground shale formations for more than 60 years. The technology continues to improve, increasing access to abundant energy sources while limiting environmental impact. Take a look at the process today in underground shale formations. The initial wellbore is drilled using a drill pipe and bit. Drilling mud is pumped down through the drill pipe to cool and lubricate the drill bit. Mud also helps stabilize the wellbore and carry the rock fragment cuttings to the surface. The drilling continues well past the aquifer or groundwater level. Thousands of feet of rock separate shale reserves from the lowest groundwater reservoir. At this point, the drill pipe and bit are removed, and a steel tube called surface casing is set inside the well. The tube stabilizes the well's sides, creating a protective barrier for both the well stream and any underground freshwater reservoirs. Cement is then pumped into the well through and out the casing, displacing any remaining drilling fluids and permanently securing the casing in place. By filling the gap between the casing and wellbore, the cement creates a seal, protecting groundwater from contamination and keeping outside materials from entering the well flow. Once the first layer of casing is in place, it is pressure tested to ensure hydrocarbons and other fluids do not seep out into the formation as they are brought to the surface. The pipe and drill bit are lowered back into the well where the drilling continues. Another layer of casing and cementing is then constructed to create a second permanent protective barrier. Multiple layers of casing and cementing are critical to safe well construction and drinking water protection. About 500 feet above the hydrocarbon-bearing shale formation, a specific downhole drilling motor with sophisticated measuring instruments begins the angle drilling to create a horizontal path to penetrate the targeted layer of gas or oil-bearing shale. Once the desired horizontal distance is reached, the casing and cementing process continues through the entire length of the wellbore. A perforating tool is then inserted into the well, creating holes in the shale layer, allowing hydrocarbons to enter the well stream. When the perforating tool is removed, fracturing fluid, made of mostly water and sand, is pumped into the well, opening tiny fractures deep into the shale. water is removed, but the sand remains, holding the fractures open and allowing gas to travel from the shale out into the well. Bridge plugs are inserted and the fracturing process repeats across the entire length of the well. Once all the fractures are completed, the plugs are removed and gas flows to the surface. The entire drilling process takes about 2 to 3 months, but hydraulic fracturing takes only days and can allow for 20 to 40 years of energy production. Combining horizontal drilling and hydraulic fracturing reduces the footprint of drilling and makes it possible to produce oil and natural gas in places where previous technologies could not.
Okay, now that you know how hydraulic fracturing works, we're going to come back and look at now some of the consequences of that. All right, and here is one of the gas wells being drilled in Pennsylvania. And when you drill down, all right, and then do your horizontal drilling, and then you do your fracturing down below in the deep layers of the earth, all right, you're going to do it, through long distances away from your actual wellhead here. All right, and you'll be pulling the gas from a long distance. You have to be careful. One of the big problems they were having, at least we think, is in Ohio. There were earthquakes, very, very small, but yet many earthquakes over a short period of time. And they think a lot of it has to do with the the hydraulic fracturing that they're doing, or the depositing of liquids that are waste products down into these faults occurring in the earth. So there's some questions about how this process is being used geologically and how it's going to affect our earth. Earthquakes was something that just came up just very shortly ago, so this is kind of new. If you want to look at hydraulic fracturing on a large scale, this is on public lands out in Wyoming. This is not a town. This is actually owned by the United States, where they allowed oil and gas drilling, and every single one of those is a well which is pulling up natural gas. Then this particular documentary came out, and it changed the whole perspective on hydraulic fracturing. It brought to light the environmental consequences and some of the issues. And I want to show you just the trailer for this. And it really is the one thing that got it started. It was shocking to people when Gasland came out to learn about what hydraulic fracturing really was.
In 2006, filmmaker Josh Fox received a letter in the mail offering him $100,000 for permission to drill for natural gas on his land. He knew that in 2005, Congress had passed a bill exempting gas companies from environmental regulations. He wanted to know what impact the drilling would have on his land, so he took his camera across the United States to discover the truth about hydraulic fracturing.
The method of gas drilling they use is called hydraulic fracturing, or fracking. It blasts a mix of water and chemicals 8,000 feet into the ground. The fracking itself is like a mini earthquake. The intense pressure breaks apart the rock and frees up the gas.
6 states have documented over 1,000 incidents of groundwater contamination.
It bubbles and hisses when it comes out. I won't drink it.
They can drill whether we like it or not.
It's a free-for-all. Our water was good before they started drilling. Then when they got done, it was bad.
Obviously, we have a problem here.
The Colorado Oil and Gas Commission is aware of the situation and will probably be doing some additional testing in the area as soon as possible.
There has been concern raised about the methods to tap these valuable resources. They have been characterized as environmentally risky and inadequately regulated. Such reports are not accurate.
The neurological effects are very insidious.
Everybody was sick, including me. I have these lesions in my brain.
You get pains all over your body.
If you weren't able to do this hydraulic fracturing, how much more would we be dependent on foreign oil and terrorism?
I have one quote here from you that says that you're trying to do this in a way that doesn't damage the environment. But you also said recently that water contamination is inevitable.
Well, yeah, I mean...
are those contradictory, or...?
Despite documented health risks and environmental impact, hydraulic fracturing is spreading across the globe.
It's amazing that what took Mother Nature millions of years to build can be destroyed in a few hours with a piece of heavy machinery.
What it's doing is searching for a problem that does not exist.
Whoa, Jesus Christ.
It's not supposed to do that.
And yes, people were shocked. Wildlife were shocked. A lot of people were upset and shocked by this. And it's happening in Pennsylvania, of all places. So we need to take a look at what's going on in Pennsylvania with gas drilling. It's happening in people's backyards. Many people are selling their rights to the oil and the gas underneath their property, and they're also leasing the land to oil and gas companies. When an oil and gas company comes in, they drill, where you see here a drill rig happening right there, where they're drilling down into the earth, and then you have these retention ponds, which are usually lined in plastic. Okay, and in the process, if you remember the video for the hydraulic fracturing, they were showing when you drill down in the well, you have to add mud. Okay, well, that mud has to come out. Also, the fracking fluid, once you put it down there, you have to withdraw the fracking fluid. And when you withdraw the fracking fluid, it has too many impurities in it, and they can't use it again. And so it gets deposited into these holding ponds and then taken away to be disposed of. So at every site, you're going to see those holding ponds next to the drilling site. Okay, and again, there's a holding pond, all right, where they have the pumps coming in. Here's a holding pond that's being filled up with the mud that was put down with the drill as they were drilling down to get into lower layers. It also requires a huge amount of water and supplies. And this is very simply a truck depot in the forest of Pennsylvania. Behind any road, you would never see this. These are all the trucks that they're using to bring in supplies and water to the site to do the drilling for natural gas. Now, the question has arisen, and the concern has come about, is what is this fracking fluid? What is fracking fluid? And fracking fluid is a chemical that's designed to keep the rocks apart and extract out the natural gas. Well, if you actually look at fracking fluid, it is 90% water, okay, somewhere around, they'll say in this case, you give it right here, 9.5% sand. So I'll give them credit for that. 9.5% sand. And then the rest, the 0.5%, is a series of chemicals for a variety of purposes. Now, we have a problem in that the sand and water is not a big deal. All right, the water is to hold the material. The sand is to be injected into the fractures of the rocks, so that and then the sand grains get lodged in there and stuck in there, keeping the fractures open for the gas to escape. But then you have all of these other ingredients. And the problem is that we don't know what some of these chemicals are. They're considered trade secrets. We don't know what's in this fracking fluid. If fracking fluid spills, we don't know what we're cleaning up. We, in many cases, have a hard time trying to decipher whether or not some of it got into drinking water, because we don't know what the signs are of it. So there's a lot of problems, and people are really concerned about fracking fluid and what exactly we're injecting into the ground. The best we can do is this diagram, just to give you some idea. Okay, if you look at it, there's all kinds of reasons for these other chemicals. A scale inhibitor for protecting the metal part of the drill, the gelling agent, pH adjusting agent. There's something to control the iron, corrosion inhibitor. Okay, there's a biocide in it. There's acids in it. a friction reducer. I mean, it just has all kinds of crazy stuff. And this is what scares people, because the fracking fluid is a material that unfortunately has a lot of chemicals mixed in with the sand and water. A health study was done, and this is just some of the results and what it could cause and some of the problems. So there is a health concern about this fracking fluid if it should ever get out. Now, in the United States, fracking is done, or hydraulic fracturing to be technically correct, is done across the United States. The scary part is there's accidents. And if you look here in Pennsylvania, we happen to have a lot of accidents. All right, and you can go across the country and see other accidents that are actually documented accidents. But in Pennsylvania, we seem to have a concentration of them across the country where we're doing the hydraulic fracturing. So in Pennsylvania, again, there's a huge concern over this hydraulic fracturing. So what is the truth? Okay, what is the actual environmental impact of hydraulic fracturing? And I think we can put it in simple terms. Okay, and I think this is the best way to put it. If monitored safely, all right, so monitored closely, monitored safely, making sure and preventing all leaks and accidents, I would say the whole process is perfectly safe. Okay? The problem is this is not done all the time. So what do you have as a problem? Okay? And these are the environmental problems. Number one is the idea of leaks of the fluid from the wells. Okay, when we're talking leaks of fluid from the wells, we're talking about as they withdraw the fracking fluid, leaks could develop because the walls of the well are concrete, and that concrete can crack, and when that cracks, it could actually leak into another old abandoned well, which you'll see in a minute, and then leak to the surface. So the fracking fluid leaking out is one of the problems. A spill is always an environmental problem. Another one is a methane leak or a methane escape. All right, and I'll show you how that works here in a little bit. But there are other big problems that we don't think about. All right, it requires a huge amount of water. If you can read my writing. Fracking is not done without the need and use of huge amounts of water. So people are always talking about the chemicals and how they can escape and how they can leak and all that kind of stuff. But we also have to think about the amount of resources we're using. And in order to do this, because you're constantly pumping down the mud and water mix, you're pumping down the fracking fluid, okay, and you're constantly using water all the time. All right, and then not only does it require a huge amount of water, but it creates large amounts of waste. And that waste is in the form of used fracking fluid, which they have to get rid of. All of these are major environmental concerns about hydraulic fracturing. Now, like I said, if monitored completely, done safely, preventing, all leaks and having redundant safety practices in there, it's safe. As safe as anything else. There's always going to be accidents, there's always going to be problems, but it's as safe as anything else. But if not monitored properly, you get all of these problems. And that's where I think the oil and gas industry got into trouble. Here's the methane release problem in a nutshell. where you have your hydraulic fracturing occurring here, okay, and the gas now comes up through your well, and then what happens is there is some sort of crack or a way for the gas, the natural gas as it's coming out, to escape, and it escapes and gets in a nearby abandoned well that was used maybe to pull natural gas out of an old layer of rock or oil out of an old layer of rock. All right, then it can go up that well and escape into the atmosphere. Okay. Now, one of the great advantages of natural gas is that it doesn't produce carbon dioxide. Therefore, it doesn't contribute as much to global warming as coal and oil do. Well, methane, all right, allowing methane gas to escape, one molecule of methane is as bad as 25 molecules of carbon dioxide. Its global warming forcing is 25 times stronger than carbon dioxide. So if you have methane leaks, you are contributing more to global warming. All right, so yeah, there's a balance here that we have to consider, and we have to think about the trade-offs. So you could have it through an abandoned well, or it could work its way slowly to the surface through somebody's water well or into somebody's basement. But the most common is this abandoned mine. And believe it or not, in Pennsylvania, there are hundreds, if not thousands, of abandoned mines. Abandoned wells out there. All right, and when we go and do hydraulic fracturing near those, our big concern is this escape of methane through the rock layers into those wells and out. All right, and that's where people run into trouble, where they see methane gas getting into their water supplies and things like that. So when you look at these videos in Dimock, Pennsylvania, a famous a place made famous by Gasland itself, you'll see, but also the methane gas in drinking water. I think you'll find these two videos very interesting to watch.
I can often hold a standard kitchen match to my water, and like I said, it is unpredictable, but the methane randomly travels with the water, and sometimes it will light quite spectacularly. Just like that.
Now, Chesapeake is going to say, well, there's natural occurring methane in the wells already. What do you have? What's your reply to a comment like that?
My reply is that their post-fracking test, their own, the methane tested 0.01 milligrams per liter, and since July of 2010, it has tested as high as 64 milligrams. So obviously something has changed.
And usually you can, they say as long as it aerates, it's safe to drink, and usually you can see a little bit of gas just aerating out of there. I don't know whether you can see it or not. Sometimes you have to hold it just right.
Yep.
So, scared? Confused? Aren't we all? Natural gas has some advantages. It's a tremendous fuel to use. But the idea of how we get it today through the shale gas and the hydraulic fracturing to get that shale gas out of the earth has some concerns. We have to be careful, and we've got to look at all the environmental consequences from the beginning of the production of natural gas to the end use and the reduction pollution. The answer, I'm sure, lies somewhere in the middle. You are now much wiser than you were before, and maybe your eyes are opened a little bit more to this process of natural gas and how we use it.